Hello all. I am here with an amazing puzzle. The puzzle is to find the smallest number of persistence 5. If you start finding persistence of each number, then it will be a very tedious task for you. But there are some logics which when implemented one can easily find out the correct answer within 10 minutes. I found it after finding persistence of just 39 numbers. So let's start with the puzzle. A number's persistence is the number of steps required to reduce it to a single digit by multiplying all its digits to obtain a second number, then multiplying all the digits of that number to obtain a third number, and so on, until a one-digit number is obtained. For example, 77 has a persistence of 4 because it requires 4 steps to reduce it to one digit. 77, 7 times 7 49, 9 times 4 36, 6 times 3 18, 8 times 1 8. This is single digit, so it is multiplied 4 times, 1 2 3 4. That's why it has a persistence of 4. The smallest number of persistence 1 is 10. The smallest number of persistence 2 is 25. The smallest number of persistence 3 is 39. The smallest number of persistence 4 is 77. What is the smallest number of persistence 5? This is the puzzle. So pause the video and give this question a try and continue once you are done with the solution. So here we begin. Before number 10, all numbers are of persistence 0. Okay. Before number 25, all numbers are either of persistence 1 or 0 because 25 is the first, or you can say 25 is the smallest 2 persistence number, smallest number of persistence 2. Before number 39, all numbers are either of persistence 2, 1 or 0. Similarly, before 77, all numbers are either of 3, 2, 1, 0. That means that to find the fifth persistence number, we need to go beyond 77. Before 77, we are not going to find the fifth persistence number. So we have started with 78, calculated the persistence 3, 78, 8 times 7 56, 6 times 5 30, then 0. Similarly, calculated persistence of 79, that comes 63, then 18, then 8. No need to calculate persistence of 80. Whenever a number consists of 0, its persistence is 1. Thus ignore the numbers containing 0. Because whenever something is multiplied by 0, it will surely gives 0, a single digit number. So it is always of persistence 1. Now 81. The persistence of 81 is same as that of 18. Because 8 times 1 or 1 times 8, both are same. So as we already found out that 18 is not of persistence 5, or below 77 we are not going to get fifth persistence number. So 18 is not a fifth persistence number. So 81 is also not a fifth persistence number by that logic. So ignore 81. Similarly 82 persistence is same as 28 persistence. So 28 is not of persistence 5, thus ignore 82 also. Similarly 83, 84, 85, 86, 87 is also needed to be ignored because 87 persistence is similar to 78 persistence. that is 3, and we already calculated that. So now we will calculate the persistence of 88. 88, 64, 24, 8, again 3 persistence. 89, we will calculate this also. 72, 14, 4, 3 persistence. Okay, again ignore 90 as it consists of 0. 91 to 98, again with the same logic. 91 is similar to 19, 92 similar to 29, 93 39, 94 49, 95 59, 96 69, and so on. So we will calculate the persistence of only 99, that is 81 and 82. Okay, so till now we have calculated 5 persistence: 1, 2, 78, 79, 88, 89, and 99. This is a table showing the persistence of each and every number at the right side. Like 63 have persistence of 2, 66 have persistence of 3. Okay, so but this is not of use for our, just for information purpose I have provided. Only one number of 4 persistence is there, 77 in 1 to 100, but this is not our interest. We are interested in 5th persistence number. Other than that, we just ignore all those things. Now persistence of 183 is same as that of 83. Why? Because whether we will multiply it by 1 or not, the persistence will be same. So 183 will also be reduced to 24, and 83 will be also reduced to 24. Similarly, 127 will also be reduced to 14, and 27 will also be reduced to 14. As there are no number of persistence 5 present in range 1 to 100, there are no number of persistence 5 present in range 101 to 202, because they both are same. Thus we have verified that no number of persistence 5 is present below 200. Okay, now ignore 200 to 210 also, because we are getting 0 as a digit in all the numbers between 200 to 210. From 211 to 219, the persistence of 211 is same as 21, or you can say the persistence of 219, 2 into 1 into 9, is same as 29, 2 times 9. So as 21 to 29 lies below 200, so no need to check for these range also. Similarly, 221 to 229, this 2 times 2, or you can say 4, directly 4 times 1, 2 times 2 times 9, or you can say 4 times 9. So this also lying below 200. So 231 to 239 also lies 61 to 69. 241 to 249 persistence is same as that of 81 to 89. Now 251 to 259. Here, whenever 5 is present and an even digit is also present, then the product will produce 0 in its digital root. What is digital root? Like 183, 8 times 3 becomes 24. So we can say 24 is the digital root of 183. So let's say 255 is there. We have taken 255. Its digital root will always contain 0 as the last digit. And if 10 is there, then next digital root will surely be a single digit, that is 0. So whenever 5 is present and an even digit is present, then that number will always be a persistence of 2. So in future we will keep this in mind, that whenever 5 is there and either 2, 4, 6, 8 is present, then that number is of persistence 2. We should ignore that because we are finding for persistence 5. After 200 we have found it till 260 and we have not found any number which is of persistence 5. Thus we have verified that no number of persistence 5 is present below 260. Now we need to find the smallest number of persistence 5. We have to focus on this word smallest. Let us say if we get 793 as a persistence 5 number, 793 is a number of persistence 5, then can this be the smallest? Is this the smallest? No, because 379 persistence is also the same as the persistence of 793, because persistence of 793 and 379 is same, and 379 is smaller than 793. So 793 can be a fifth persistence number, but it cannot be the smallest number. Similarly, let's say if 473 is a fifth persistence number, then is this the smallest also? No, obviously not. In fact, 267 is the smallest. If 473 is the fifth persistence number, then 267 will be the smallest fifth persistence number. This 2 times 2 times 3 times 7, so only 2 remains at the 100 place, and 2 times 3 at 10th place, and then 7. So we can conclude here that the digits of the smallest number of persistence 5 are either in ascending order or all the digits will be same. So our answer can be either 333, 555, 444, or it should be increasing like 457, 468. It can't be 463. It will always in ascending order, or it should be always same. This is one of the conclusion. Now currently, as we are looking for 3-digit numbers only, let us see which digits can be possibly placed at the 10th place. At this 10th place, what digits can be placed? If 1 is at 10th place, okay, then only 1 can be placed at the 100th place, because at 100th place this should be lesser than the 10th place digit or equal to the 10th place digit. So we are placing 1 here. As we have seen, 110 to 119 does not consist of fifth persistence number. Yes, we have checked that till 260 no fifth persistence number is coming, thus ignore this combination. In fact, 1 can never come at 100 place, because we have already checked that 100 to 199 no fifth persistence number is present there. So 1 can never be at 100 place, as we have checked persistence till 260. So if 2 at the 10th place, we had kept 1 at the 10th place, but we have ignored this combination. Now keeping 2 at the 10th place, we can't keep 1 at the 100th place now. This is clear from here. So now keeping 2 at the 100th place and 2 at the 10th place also, we can see that this is ranging from 220 to 229, and we have calculated till 260. So this also does not consist of number of persistence 5, because this combination is also needed to be ignored. 230 to 239, this is also lying below 260. 330 to 339, this is lying above 260, but 331 to 339 have same persistence as 91 to 99. 3 times 3 is 9, so 91 to 99, and this is lying below 260. So this combination is also ignored. 240 to 249. This is also similar to 81 to 89. 2 times 4 is 8. 3 times 4. This is interesting. 340 to 349. This can be fifth persistence number, but this cannot be the smallest, as 341 can be written as 261 also. Means in persistence term, that the persistence of 261 is same as persistence of 341. Persistence of 269 is same as persistence of 349, and 269 is smaller than 349. So 341 to 349, we need not to check there that is this the smallest possible fifth persistence number. No, we need not to check, because instead this will be the smallest possible fifth persistence number. So we ignore this combination. 440 to 449, again this also, this can be this the persistence of 449 can be is the same as the persistence of 289, and 289 is smaller. So again we are ignoring this combination, because this can't be the smallest possible fifth persistence number. The smallest can be this 281 to 289. We have to check this 281 to 289. We have to check this 261 to 269. That will come later. This combination 5 with an even digit. This is of persistence 2. So we need not to check this also. Now keeping 5 and 3 here. Yes, this combination is needed to be checked, because this is not lying below 260. This is an eligible fifth persistence number. This can be an eligible fifth persistence number, and we can't find any other number which is lesser than this combination. So this combination is allowed. 5 this combination is also allowed, because again the same logic, it is not lesser than 260, and we cannot find any smaller number than this whose persistence is same as this persistence of this range. Now 260 to 269, this is also needed to be checked. This is greater than 260, and no other range persistence is same as this one, which is lying less than 260. So this is also need to be checked. 360 to 369. Okay, this can be means the persistence of this is same as the persistence of 291 to 299, and this is smaller than this combination. So we need not to check this combination. Instead we should check 291 to 299. Okay. Similarly 461 to 469. This is similar to 381 to 389. So we will check 381 to 389, not 461 to 469 combination. Here 661 to 669. This is also, instead of that we should calculate the persistence of 491 to 499. You can see here that 6 times 6, or you can say 2 times 2 times 3 times 3, so 4 times 9. So both persistence are same, and this is smaller, so we'll check 491 to 499. Now placing 7 at the 10th place, we see that each and every except 1, each and every other digit lesser than or equal to 7 is an eligible combination. So we should check that also, because this is not coming less than 260, and there is no other number whose persistence is same as this number. So we need to check 270, 370, 470 range, 570 range, 670 range, 770 range. Similarly, 280 range, 380 range, 480 range, not 580 range here, because 5 with an even number always produce a persistence of 2. So we have omitted that. 680, 780, 880. With 9 also, each and every combination, including 5 here, each and every combination is needed to be checked. Now, what range we need to check? 261 to 299, 351 to 359, and 371 to 379, 471 to 499, 551 to 559, 571 to 579, 591 to 599. This is because we have omitted that even part. 671 to 699, 771 to 799, 881 to 899, 991 to 999. Still there is a lot of number. So let's look. Now from 200 to 300, as we have seen that we have to look from 261 to 299. But we can see here that the persistence of 262 is same as persistence of 226, and we have checked below 260 that no persistence of 5 is there. So this is not of persistence 5. That means this is also not of persistence 5. Similarly, 263 is same as 236. The persistence of 236 and persistence of 263 are same. And below 260 we have found out that there no 5 persistence number are there. Similarly, 264 is 246, similar 265 and 256, as we have calculated below 260. So we need not to calculate till this also 265, but we need to calculate the persistence of 266, 267, 268, 269. Again, this is not needed to be calculated because this is similar to 227, 237, 247, 257, 267. We have calculated this. After calculating these 4 persistence, we are proceeding further. So we have calculated this. So 276 is also not needed to be calculated. 277 is needed to be calculated. 78, 79. Similarly, 287 is also not needed to be calculated because you have calculated this. 288, 289, 299. So in 200 to 300, we have to calculate 4, 3, 2, 1, 10 numbers. We have to calculate the persistence of 10 numbers. In 300 to 400, 350s were included, then 370s to 390s. In 350 again, we have to start from 355, below which 354 and 345 persistence are same. So we have to start from 355, then 357, then 359. Then why we have not taken this 356? Because 5 is with an even digit. 5 is with an even digit, and this will be of persistence 2. Now 360s were not included in the case. 370s were included. 377, 378, 379, 388, 389, 399. So 6 numbers here and 9 numbers from 300 to 400. So we have started calculating the persistence of each of them. 266, 267, the 10 numbers from 200. We have calculated the persistence 334242, and from 300 9 numbers are there. From 400, 470s to 490s, they were included. So those are the 6 numbers: 477, 78, 79, 88, 89 and 99. 88, 89 and 99. 6 digits from 400. From 500, what happened is 550s were included, 570s were included, and 590s were included. In 550s, we should start with 555, because before 553 is persistence of that is similar to 535, so those are not needed to be checked. 555, 557, 559. Okay, then in 70s again start from 577, 579. Why we are skipping 578? Because even digit should not be included with 5, that will be of persistence 2. So after 579 we come to 590s. In 590s only one number, 599. So we have calculated the persistence of, again here, 6 from 500 to 600. Then calculated 677, 678, 679. In 600 we have to start from 670s to 690s, and as we proceeded 679 is the number of persistence 5. So we have calculated till now 39 numbers in total. Like you can see here, 10 numbers from 200, 3, 9, 19, 6 from 4, 19, 6, 25, 25 and 6 from 5, 31, 32, 33, 34, 34 there, and 5 persistence we have calculated in the beginning. In the beginning we have calculated these 1, 2, 3, 4, 5. So by calculating 5 numbers persistence and here 34 numbers persistence, we are able to get the 5th persistence number, which is 679. Thank you for watching. Please like, share, subscribe the channel for more such amazing puzzles.